Um, Welcome to this third and final webinar in our series on smart product exploration and concept validation. Today we're going to discuss the actual solution exploration and its validation. My name is Geert Willems and I will start with a bit of a theoretical introduction about the system analysis, verification and validation processes as they are defined by the ISO IEC IEEE system engineering standards. I will start with a short introduction and then go to the processes, the evaluation processes we just have mentioned. And do not forget that the main purpose of this activity is to avoid what Wally in the Dilbert cartoon is calling the doomed project by doing a proper preparation before you start actually designing and developing your product. In this series, we are focusing on the first stage of product development, which we call the new product exploration stage, which also sometimes is called the concept stage. And there we focus on research, understanding the problem and the solution to that problem. And this must result in a validated concept on which the product requirements can be defined, the product development can be planned, and then in the NPI, the new product introduction stage, we actually do the product design, prototyping, qualification, and industrialization. The key questions we want to answer in this exploration stage are: what do our customers and stakeholders need? The need. What can we offer to answer that need? And of course, how can we make some money with this activity? The challenge we are facing with so-called smart products is that we have to deal with a lot of complexity related to the broad range of technologies and disciplines we have to cover. And for that, we are looking towards the system engineering standards, and especially those that are mentioned there, and also which are further discussed, give a lot of more background in the system engineering handbook of the International Council on System Engineering. And that's, let's say, the framework which we're going to use to tackle this smart product challenge. This system engineering standard, specifically the 15288 on system lifecycle processes, defines 4 categories of lifecycle processes. We have the technical processes in red, where you have realization, evaluation, operation, and disposal processes. These are supported with project management processes in blue. We have the agreement processes to acquire the services and the parts that we need and to supply the product that we are going to develop. And all this is supported by organizational processes. Our focus in this webinar series is on the technical processes. And in the previous webinar, we focused on the business analysis and the stakeholder needs, which are the core technical processes in the exploration stage. In this webinar, we're going to focus on the evaluation processes, system analysis, verification, and validation. And actually, these are processes that are being used throughout the complete life cycle of the product, and dus also by all the other technical processes to realize their to support their activities and realize their outcomes. Okay, let us start with the system analysis. The purpose of the system analysis is to provide a rigorous basis of data and information for technical understanding to aid decision making across the life cycle. So the important or the main purpose of the system analysis is to understand, to gather information, to create insights on which we can decide what to do. There's also there's it's called system analysis, but you should not read this as analysis of the system. Rather, it is analysis for system engineering, and it is being used throughout the whole life cycle, also in the very early stages where there is not a system yet, but we're going to define that's this. The activities in system analysis consist of different, or there are different activities, starting with the preparation, and this involves identifying the thing we want to analyze, identify the stakeholders, who is going to benefit from the analysis that we are doing. We have to define the scope, the objectives, and also very important, the level of fidelity. How good must the analysis be? And then we have to select the analysis methods. And unfortunately, the sky is the limit is in reality rarely the case. And we have to take into account certain boundaries. For example, the time we can spend on the analysis and how much that it may cost. These are important criteria and are related, of course, to the level of fidelity and the criticality of what we need to analyze. The way we analyze can be done in many ways. There's a list there. Judgment by experiments, very simple back of the envelope calculations, and it can go further towards spreadsheet engineering, spreadsheet computation, engineering model simulation, etc., even prototyping as such. And of course, we have to make sure, and I will not repeat it always, that we define the strategy and they have all the systems available or services available that support the analysis itself. After preparation, we have to perform the system analysis, and usually we have to make some assumptions. That it's very important then to identify those and validate whether these assumptions are really valid. You have to perform the system analysis, review the results for quality and validity, and make some conclusions and recommendations and make a report out of that. And all this needs to be managed, be traceable, and provide and formulate in a way that it can be used for baselines. These are the, let's say, the basis on which the further product development will rely upon. If you look specifically in the exploration stage, and specifically towards the activities we do there, the business mission analysis, as the name says it's an analysis activity. So the system analysis is, let's say, the main activity in this technical process. And what do we analyze? Well, the own organization's mission and strategy and possible gaps that exist between where the organization is now and where it wants to go to. Then we have the problem opportunity and solution space analysis. And then also in the mission analysis, we create certain, or we identify certain candidate solutions classes. For that, we are going to analyze the risk, the feasibility, value, cost, effectiveness, etc. So this process is really about system analysis with some additional definition and of requirements. In the stakeholder needs and requirement definition process, we analyze the needs. And based on that analysis, we're going to define or set the priorities in these needs. We analyze the life cycle concept and then the requirements we are going to establish. And if the required analysis, we really focus on feasibility, cost, risks, and effectiveness. The techniques that we use in this exploration stage are, for example, as a basis, and in the very early stage, desk research, interview service, low-cost approaches to establish what is the problem and what are the first ideas about the needs. For the business, we can use business models, analytics, simulations. For things like user experience, we can go for living lab experiments and some prototyping there, and we can consult experts to help this. Thomas, my colleague, will in the second part go deeper into examples of these techniques and how they can be employed. Then we have the verification process. And the purpose of the verification process is to provide objective evidence that a system or system element fulfills its specified requirements and characteristics. It's mainly aimed at checking whether the system is built right, that it's everything what is done is in line with the requirements that have been set. So it's all about checking that the requirements that have been established are met by whatever is following after that requirements. That means that the requirements itself are really important and need to have specific properties like being quantitative, being measurable, being unambiguous, being understandable, testable, etc. Actually, setting up requirements is an art of its own. And there is also an ISO standard which can help on that, the 29148 requirements engineering standard. The activities in the verification process are again starting with the preparation. We have to identify what we actually are going to verify and how we're going to do that. Identify certain constraints, which makes it or which limit what you can verify or what you can do in the verification process, and then select the methods, techniques, and criteria for the verification itself. And again, strategy, architecture, strategy and obtaining the enabling systems. But also here, we have to take into account that the verification process, and that can be tests, the testability of your products may have or may put constraints on your system requirements, on the architecture, on your design. That is also something that you have to look at when you define the verification process for a specific aspect of your system. We define and perform the verification procedures, and then we have to manage all this. And that means that, of course, we have to record the results, but also any anomalies, any incidents or problems that have or that are encountered when you perform the verification. And once you've done the verification, you have to get the agreement of the stakeholder, whoever wants to have this verification results, that you are actually meeting the requirements that you are verifying. And all this must be traceable for the remainder of the life cycle of the product. The techniques that you can use are inspection, analysis as such, again, analysis as we have defined before, but in this case we analyze against a certain requirement and check whether this requirement is fulfilled. And this can, apart from inspection and demonstration, test and sampling, involve calculation using some logic, modeling, simulation, analogy, or similarity. Now, what are we using the verification process for in the new product exploration stage? Because at that moment they are not that, the system is far from being specified. Well, I said that the requirements specification is an art on its own, and these requirements, they must be necessary, implementation free, and so on. They have a lot of criteria they need to be met, and for that there are some rules in how to specify requirements, some syntax, some grammatical rules, and one verification task that is or need to be done in the exploration stages. Once we set up the requirements, do they fulfill these rules? That's an example of verification in the exploration stage. In the business mission analysis, we are establishing business requirements. So, and apart from that, we look at the business models and the solutions classes. So we have to check the proposals for business model and solutions classes, whether or not they fulfill the business requirements we have established. And something similar in the stakeholder needs and requirements definition, where we establish life cycle concepts, and again, they have to fulfill the requirements for business and the stakeholder requirements. Then we go to the validation process, and that is slightly different, but not very much different. But the purpose is different from the verification process in the sense that it wants to provide objective evidence that the system, when in use, fulfills its business or mission objectives and stakeholder requirements, and that it achieves its intended use in its intended operational environment. So where verification is about, is the system being built right? Is it built according to the requirements? Here we go actually more in depth and check whether the right system is being built. So we check against the needs. The activities are actually the same as the verification activities. You find the same wording in the standards by just replacing the verification by the validation part. But the difference is that where we check against the needs and not against the requirements. In the exploration stage, I would say validation is probably the most important activity, or is actually the goal we are looking for, because we were going to a validated concept of a solution for a certain problem. So it's about validation of the business and stakeholder requirements and about validation of the lifecycle concept and the solution classes, and check whether these are answering the business and the stakeholder needs. The techniques that are used for validation are the same as for verification, but with the intention to prove satisfaction of the needs instead of detecting errors or defects with respect to the requirements. As a final slide, I give here an overview of the different activities in the exploration stage, where we have the two core, let me use the laser pointer, we have the two core life cycle processes, the business mission analysis and the stakeholder needs, and also some preparation activities where we look at all the other technical and agreement processes and check what their impact would be on the requirements we are establishing, or vice versa. Analysis, system analysis is happening everywhere, is a very important part of the exploration activities. What I also indicated here are what are the references for validation, the needs, and this problem solution space. We talked last webinar about the problem space statement is the reference for checking whether you're really addressing the proper problem and that the solution is really addressing the needs of the stakeholders, which are gathered or let's say written down in a stakeholder needs statement. For the verification reference then are the requirements, the business requirement specification, which may also contain some business needs, and the stakeholder requirement specification. Okay, this was the theoretical introduction, and then I give the virtual floor to my colleague Thomas for his part. of this seminar.
Thank you, Geert. I'm gonna share my screen. Can you see my screen?
Yes, I can see it.
Yes.
Okay, so thank you, Geert. So basically, I'm gonna do the same every webinar. We've introduced this, let's say, a case where, let's say, you want to go from an ordinary coffee machine to, let's say, a more smart coffee machine. And so, I mean, you can add a lot of new functionalities. You might need, a smartphone application or add some voice commands. So basically, what it actually means is that we evolve from having, let's say, the competences that you already had in your company, like customer, suppliers, to actually new competences, new partners, new business models. So it's actually the fact that we're going from something known to something unknown. This is actually the actual challenge, the notion of smart intelligence, sensors, and communication. In essence, doesn't mean a lot. What we call smart today in 5 years is not smart, and what we call today. What we called smart 5 years ago what is not really considered smart now. So it's most about that going into this unknown that requires a sort of a structure, and that's actually the approach that we follow. So during the last sessions, we've basically introduced this, let's say, iterative process where you start with business requirements, basically the reason for actually innovating in a smart coffee machine, and then going to stakeholder needs, lifecycle concepts, etc. So today we're going to start with lifecycle concepts and go all the way to the end. But what I want to say here is so it looks like a chronological process, but for sure it's iteratively. And if you learn things while doing lifecycle concepts and let's say prototyping and testing, of course, that reflects on, let's say, stakeholder needs and also business requirements. So it's an iterative process. And actually what is actually happening is that the knowledge of your product concept is actually maturing with every phase. So what we actually want to do during all of these steps is explore and validate the concept, and that means that we create the entire story. So that doesn't mean only functionality, it's the whole product life cycle, and that also includes business models, but also, let's say, how to produce these things, the unboxing to give you the first use experience, etc., etc. So it's basically everything that concises the product and also the things that happen in the organization to make this happen. So yeah, I mean, in the end, we have a business and a reason for innovating. We actually have stakeholders, maybe because of customers, for who we are actually innovating for. And then actually what these things do come together in a concept. And actually what we're going to try to do, and that's what we're trying to do today, is validate that concept, both the business part as the stakeholder needs part, and actually how that solution fits with what we do. So what we do is analyze, evaluate, and of course, validate. We're going to start with the life cycle concepts. I have to be honest, I have a lot of slides. You're more than welcome to interrupt me if you have a question, because it might be that I run through some of them. So make sure that you just interrupt me or have Geert interrupt me. It doesn't really matter. So the life cycle concepts is basically the studies, the in-depth studies to evaluate multiple, let's say, candidate concept, alternative solution classes. And the goal, the objective is to gather data that can actually, that provides evidence for a certain business case and for certain technology or solution concepts. So we want to verify feasibility, whether that we're actually meeting stakeholder needs, that we can, we try to explore different trade-offs architecturally, but also technology. And of course, we explore and validate, hopefully, certain risks that go along and maybe discover some opportunities. So actually, we want to validate, definitely in this phase, is we validate whether that concept is desirable. Do we meet the stakeholder needs? Are we able to solve them? Is it feasible? So can we make it? But it's definitely also technology readiness. Do we have the expertise available? And then, of course, is it viable? So can we actually make money with it? That's goes to actually the profitable profit, but it goes to how does the market look, who's my competitor, and so it's basically validating all of these. We go validate them, looking for solutions, see if they meet the stakeholder needs that can lead to new opportunities or problem space, etc., etc. During this life cycle concept, we do a lot of things. I think it's the biggest step because it basically covers both the business and the market aspect. I've only listed these 4. They cover a lot. So, I mean, first of all, we have to identify risks, and they can be technical risks, but I mean, in general, we want to research and analyze these risks and come up with certain options that we have and what the implications are of them, of course. So then we go into concept validation, and then I give you a little bit of a living lab sprint, something that we do here in IMEC, and then a last part about business modeling. So I'm going to start with risks. It's quite straightforward. Risk has 2 components: the probability, and then of course the consequence of when it happens, what the results are. And we have 4 types of risks. Of course, I think in this phase we are mostly concerned with technical risks. And what if a certain system fails to achieve the certain performance requirements that we need? So that has, of course, impacts on the whole project. But there's, of course, also the cost part, the schedule part, and also programmatic. Of course, these all influence each other. But I think in this phase in the life cycle, creating this life cycle concept, I think the technical part is what we actually want to analyze and validate. So basically, how to treat these risks. I think the most important one here is that we do feasibility studies to actually establish evidence and explore certain alternatives that we have. So the aim is actually to rapidly, let's say, gather evidence by testing certain features, components, product concepts, both whether they're desirable, feasible, and viable. And of course, this testing can be highly quantified, let's say, gathering a lot of data, but it can also be more subtle, can be look and feel, can be material properties, tactile nature of a button, for example, mechanical aspects. And of course, not very important is we're always looking to meet the stakeholder needs. So user opinion in general is a good way as a part of the feasibility studies. Of course, that's not the only risk, but I think in terms of the technical risk, it's the most important one. There's a list of techniques. I'm not going to go into detail. I think the most important one is, of course, as a project team, you have certain judgment and let's say gut feeling. This is already a very good basis, but of course also experts and interviews specifically for certain domains are very good. And then next to that, you have a whole list of actual simulations and the FMEA analysis. So these are all techniques. I'm not going very in detail. Next, then we have this concept validation. I think it's for me, at least in this presentation, it's the core of what we're actually trying to do with COOCK Smart Products. Is actually give a little bit an idea and insight in what the process is to innovate. And this part is really important because it really brings back together what solution that we have and where it's actually meeting the business and also the stakeholder needs. So what we do strictly concerned with exploring and validating these technical market and business aspects of that solution concept that we have in mind. So, I mean, we focus on those that are of key importance and mainly that actually have a certain risk in them. I mean, let's say that, for example, the development of an app is a commodity. So, I mean, I would not really develop an app. We can make some designs to see about user experience, but the app itself is something that we know we can do, except if that app, of course, has to do certain aspects, and an application on a cell phone has to do certain aspects that are very novel, then of course this can be part of your concept validation. So we want to answer these let's say fundamental questions about the product. We use this phase to compare, choose the best solution. It's also communicating ideas to, let's say, the stakeholders internally or to clients, and of course demonstrate functionality and gather feedback. And not unimportant is also to see whether we encounter, let's say, unexpected problems or have some conceptual flaws that only goes when you actually try and test. A product or a smart product consists of a lot of things. You can see it's electronics, it's mechanics, there's a part of integrations, you have dimensions, look and feel, you have the, let's say, the packaging and enclosure, you have material properties. It's not always as relevant. If I make a coffee machine, maybe it's worthwhile to inspect certain material properties because it might get very hot or it might melt. But in general, not everything has to be looked at closely. Certain things can just be accepted as a certain small risk because the consequence will be low. If we're thinking of prototyping with the idea of validation, I think there's three very important parts, or let's say how shall I say, the three types of prototypes. So you have everything related to the role. Basically, that addresses how the solution concept will actually be used or will serve the user or customer. We have the look and feel part, so that's form, color, interaction, usability, let's say your own branding, and that's actually looking for how shall this actually look. And then we have the implementation part, which is actually the functionality of that prototype. If we bring these three together, and that's the role, how will it be used, the implementation, the functionality itself, and can we actually make it a technical feasibility and look and feel, then we're integrating this. So that's actually a later step. Besides these types of prototypes, digitally, physically, there's also, and Geert already mentioned it, also the fidelity, the degree to which your design actually resembles, let's say, the final product. Low fidelity, of course, is made out of very cheap materials or done with little effort, while high fidelity are actually already representing aspects, or at least certain aspects are representing the final product. It's more professional, let's say, and typically they probably integrate multiple components instead of being certain aspects in isolation. If we have that, yeah, then the goal is we don't just prototype. No, we want to actually find let's say answer certain risks that we have. So typically what you want to do is, it's not per se formal hypothesis, but you create a hypothesis in which you're actually looking for an answer. So once you have that hypothesis, you start a design experiments. You can test and validate these things, and with the data that these generate, you have insights, which then of course makes you go to the next step. Within IMEC, we often use the Innovatrix. It's an innovation canvas. It's a little bit like a business model canvas, but with more focus on, let's say, the customer segment and what we're actually proposing to them. But it helps gather and validate assumptions, and it actually, in the case of concept validation, it also helps you identify what aspects might be risky. So what we then do, of course, we create a hypothesis around that assumption and then make a design experiment. You can see it consists of 8 criteria, and yeah, like I said, it's basically an assumption-based philosophy to and actually innovating, where we map these assumptions under each of the relevant criteria. Yeah.
Thomas, can I just ask a question here at this point?
Of course, yes.
So what I find is that during the concept phase, the stakeholder needs, they're not very clear all the time. Sometimes they're not completely quantified. So you kind of have to, when you start designing the concepts, you go into kind of iterative process where you take the first steps into concepts, run that by the stakeholders again, and then maybe change directions to some degree. I'm not sure how would you see that to be done in the most efficient way? I can develop high fidelity prototypes in this space, for example, but that's going to be very expensive to do that.
Yeah.
I'm trying to come up with a way how to optimize such a situation where capturing the needs in the best way and then having the low cost path towards the most optimum concept?
Yeah, it's a good question. I believe you were not present in the last webinar we did, so
No, I wasn't.
back to maybe take the overview one. So basically, typically what you do, there's a reason. Let's say management comes up with an idea that's, let's say, the start of a business requirement. I just more coming into it, but basically it's the reason for an organization to innovate. And then typically, and that's also the process that internally we try to follow. I'm not going to say that every time. It's not this is not a straight path forward. It's a curvy path. You can take shortcuts, sometimes you don't. But typically what we would do if we have an idea is maybe first, let's say, consult some experts, try to refine a little bit that idea, and then maybe also try to look already at who could be a customer segment or stakeholder segment that can actually input us. So as I explained during this stakeholder needs analysis phase, it's not that you only are interested in doing, let's say, an interview or an observation. Normally, typically from that idea that comes from, let's say, management, you try to already create a certain life cycle concept. So a certain concept, like, let's say that we want to go to a smart coffee machine, like I said. Yeah, you can do a lot with that coffee machine. Like I said, you can do voice commands, you could do an application, you can actually go more into, let's say, automated service. There's certain services like automation of your orders. I mean, there's a lot of ways, but typically if you start defining this is going to be my customer segment, you try to define maybe we should go to more of these applications where someone doesn't have to actually physically interact with that coffee machine. So you go to voice commands or an application. So you try to define rough lifecycle concepts that you then, of course, can validate with stakeholder needs. And if you would do an interview, of course, have them suggest the same without actually asking the question. So look and discover needs. Why am I saying this? Because when we get to lifecycle concepts, we try to already have feedback and input from a stakeholder or a customer in this case, so that we can actually roughly define, okay, a stakeholder is more interested in, let's say, these non-physical interactions with the coffee machine. So we start defining that we might look into Alexa as a voice command, but also look into maybe creating some app screens and see how user experiences. So you already define, and then of course, as I mentioned here, we don't start with high fidelity mockups, both physically as digitally. No, we try to, I mean, definitely for user experience, you can go very cheap without having to really design a lot. So I'm gonna come back to that, but I think it's very important that you have a certain idea in mind, and you along the way it matures and you get further input and validation. So it's not like the stakeholder's not involved. I'm sorry.
I think
I
you're
think we
also
have
saying
to.
we should probably look back into the material from the previous seminar.
Yeah, I would refer to the first webinar where we talk about the stage gating, and where we start with a very low cost first assessment, and that's important to get the first idea in a low cost way, and then gradually build up, and that you have to manage that. But I think now we have to continue with the.
Yeah. I'll just continue. So these are a whole set of typical techniques that we suggest that you do for discovering the role of what smart product concept you have in mind. That typically storyboarding, you can observe how stakeholders do that. But I'm actually gonna use the dip jar example. So I'm sorry, it's not a smart coffee machine, but you can look for this as well online. So dip jar is a way to tip with a credit card or a debit card. And the interesting part here is they actually documented most of their whole engineering approach. And so for term of when looking at role, I have this picture of the dip jar. Basically what they started with is making a very rough design of it. I mean, it's 3D printed, I believe, and with a metal plate, but they already put this very early to see whether people can actually figure out that you have to tip with your credit card, and they put a number on it, 5 seconds, when they're at the counter doing a transaction. And so then of course they look for different role models between brackets, where one of them you can also leave cash, or is a credit card preferred. So, and of course, it's also looking at actually, there's two people at the counter, there's the client and there's someone selling it. So are they also supportive of that ID? So basically, this is a process that they followed. So they actually just put this in different counters to see and observe whether people were actually able to use the dip jar. So this is a very good example of role. I think the design looks already very beautiful, but in general, this can be a very, very rough thing. It can actually also be a sort of a role play. It's just about basically getting an idea how it will be used and what is actually most practical. So the look and feel of it is actually of a lesser importance. Of course, there's also look and feel prototypes. You go from sketches all the way to actually rapid prototyping certain hardware to, of course, get and create a physical model of the product. So the techniques I give here build up fidelity, both physically but also digitally. I'm not going to go into detail, but I'm going to go back to DipJar to show you that it's not one activity. And it's a smart product, so there's an app part and our website part, and there's an actual physical aspect, the actual prototype, the physical one. So you see that they took a whole set of steps going from sketching how app and web could look like and making it should be like this, going to the form factor, the dimensions, to the actual design language or the way that the product would actually be communicating to you, and then of course ending with mock-ups, clickable mock-ups, and an actual prototype that looks like the dip jar that we know today. So you see a lot of different prototyping activities are done, but they're done, but some of them done parallelly. But of course, you first design and very cheaply design how that app might look like before you actually already create mockups to get an idea of user experience. And of course, you can use a living lab or get customers to actually give feedback very early in that phase. So that's actually the goal. Last, but I don't think definitely not least, is the whole implementation prototype. Basically works like prototypes, types of prototype. So it's a lot. You have a lot of different techniques. I listed things that I think are very important when looking at smart products. So you have development kits. Think of an Arduino or Raspberry Pi, where you can create actually very functional prototypes. You have off-the-shelf software and components. Think of open source libraries, but it can also be breadboards, sensors that might also work together with those development kits. You can 3D print mechanical parts. There's low-code and no-code development. There's simulations that you can run on, let's say, 3D prototypes to actually calculate certain parameters that are not observable. And then you can actually also print or create customized hardware and software. Think of if a large aspect of my solution might be, let's say, an AI algorithm, then you probably will actually customize already that software because it's the core of what you want to offer. If you cannot create this, then why pour more money in it? So we're strictly concerned here with functionality. Can it work and is it achievable? So of course, DipJar did that too. You could already see the form factor, look and feel, but here they're actually more concerned in assembling the functionality. I think they went a little bit too far in what I would suggest you do, but you can see that they have been looking at first core functionality and actually because you cannot really see it very well, but they actually also started with a Raspberry Pi, but then ended with custom printed PCB. So I mean, you see the metal, plastics, the tactile, the material that they would use, the assembly part, and then of course at the end they end up with an actual prototype that works like it. They even went further. I think that's for the next. It's not a new product exploration; it's already planning and development. But they went also to actually exploring how this assembly could be further optimized, etc., etc. As a last part, so when we create these prototypes, that's very good. I'm very happy with that. But of course, you also have to test them. There's a lot of steps. You can do experiments and field testing. So that means it's actually testing a product in either a controlled environment or actually in an outdoor environment of an in-situ environment. You have Wizard of Oz, something that we use a lot within IMEC. The Living Labs is basically involving users, customers or stakeholders very early and actually having them give feedback. I think it's also now known, for example, communities of practice are also a very good example of what is, let's say, a lightweight Living Labs. AB testing, simulations, as I mentioned as well. You have usability and UX testing. So I have links to often the Wikipedia page, but sometimes also other. I have some pictures of us at IMEC doing Wizard of Oz. I will just explain it. What you can see is my colleague Wout, who is actually at the right side interviewing someone, and someone else, which was Wouter, to not make it more confusing, that is actually controlling that little box that you can see. So the moment that person clicks on something, he will actually play a sound to mimic the fact that that box would be talking to him. At the other one is another project. At the left side, you can see Wout at the distance actually taking an interview with the actual box as well, while the colleague is actually looking and is actually also again using the BCFE in this case to actually mimic like the functionality would be working. I have another video, but I'm not going to show it. I tried it with Geert. It was not a big success. But this is, again, the Wizard of Oz technique means that you try to mimic whether it would actually be working. But actually, in fact, it's not working, or it's lacking a lot of components to be actually working. So we create, in this case, it's Trash Talk, where you would actually pick up trash and talk to the application, and the application would talk back to you. In this case, it was actually a phone call with a beautifully designed screen visible. Wait, I didn't know that was going to play. Then we have the Living Lab sprint. It basically condenses these activities in, like I said, formulating an hypothesis and then making design experiments, studying and testing and learning. So basically a Living Lab sprint, the sprint means that you try to condense this in a relatively short period of time. That depends a little bit of what type of project you're doing. Sometimes it can take 1 week sprint, but it could as well take 10 weeks. And for hardware, I think it takes more time than for software, so be that, but it's a design challenge. You explore and validate. We typically do that in a Living Lab, and we involve all relevant stakeholders. Last part of these lifecycle concepts, which I did not touch, is the actual business models. As everyone knows, is how businesses create, deliver, and capture market value, let's say. This is an overview of what you have. You have a financial value proposition and a financial model, and then a network to actually deliver that. And then, of course, the internal organizational architecture. There's a lot of things going on. I'm going to bike a little bit through it. You have different frameworks, like I said, Innovatrix, but also the business model canvas, Link canvas. There's a lot of these frameworks that help you visualize the choices and consequences. Or translating them at least. And the goal of these frameworks is to create, like I said, let's say a schematic overview that explains your business model. Next to that, you of course have techniques to actually get an idea of who your market is, like TAM, SAM, SOM, so total addressable market, serviceable addressable market, and serviceable obtainable market. But you also have, of course, your own sales. I mean, it's not like you go all the way in the unknown. So there's typically, you have some own sales and service of your own customers that can help. So this is a TAM, SAM, SOM. I'm not going to go into that. I have no time. There's of course also the value proposition part. So again, there's quite some canvases, but in this case, there's actually quite good tests, like a landing page test, which we also at IMEC quite often use, which is actually you make some advertisements, which is relatively cheap digitally online, where you actually make one page where you actually try to come with a message to see how successful that message is with, let's say, people visiting that website. So it's actually not offering anything, but it's actually the offer that you have in mind, actually doing it already online and see how successful that is. And typically what you do is try to get an email of someone that would be interested. You can also, of course, show your value proposition in infographics, and you can do competitive analysis and benchmark yourself versus your competitors to create, let's say, differentiate yourself from that competitor. What I would also suggest might be known for you is from Bain & Company has actually, let's say, they have different values which you can actually use to create your value proposition, going from at the bottom all the way up, where they say that the higher your value is, the better it actually translates to a potential customer. Of course, it's very difficult. It's not always very straightforward, but you can see there's a functional value proposition, which is of course not bad. But if you go already a more emotional value proposition, then you actually gain into, let's say, importance for that customer segment. Something to think of. Besides value proposition and besides that market, there's of course the business model itself. I didn't go very far, but there's quite different business models to think of. Definitely, if you go to smart products, you can do direct sales, but you can also sell software directly or services. You can do coffee as a service, where you not only sell a coffee machine, or you maybe sell it a little bit cheaper, but you are able, like ink cartridges, actually able to also sell a service next to that every month you deliver that many coffee. You can do licensing of your coffee machine or renting it, leasing or renting it, of course, licensing, no. And you also have to have the franchise, in this case, not so relevant. Next to that business model, there's also a revenue model. So it's the way that you actually generate profit or generate income. There's, as I say, the one-off sales, but there's also a sort of a pay-per-use, which for a coffee machine would maybe be weird, but think of the Totals of this world. They actually have these coffee machines where you pay for every time you get coffee. So it's definitely something relevant. And then, of course, these other ones, I think what is important here is these revenue models either focus more on, let's say, product sales or service sales. And then in between, maybe you can also sell data. I think for the coffee machine example, it's really difficult to think of that, except, for example, I think you could think of a Starbucks that gathers a lot of data about their customers. They might actually be able to use that data, maybe sell that data, or use that data to create new revenue streams. Yeah, if you think more of a product, then it's a smart coffee machine with these voice commands, like I said, Wi-Fi and application. You sell actually a product and functionality, but you could go more into services where you get automated maintenance, automatic orders, data analytics. So that's actually a service that you offer to a user. So these are the things to think of. This actually, of course, like I said, you try to validate these things in terms of, if you look at business models, it's also maybe important to know that it's often, if you have a competition or a competitive landscape that already does certain business models or revenue models, that it's sometimes very difficult to go another way. So it's interesting to think of freemium. But if none of your competitors are doing this, you might be having a wrong business model. So it's all, I mean, take into account that it's not only you who defines how that business model actually looks like. As a last part, maybe of you validate a lot of aspects, technology, stakeholder needs, then you evolve towards being able to actually create customer requirements, stakeholder requirements. So basically a complete description of these features that you have validated and how that product lifecycle concept actually looks like. So the objective is to describe what actually must happen to meet, let's say, a stakeholder need, organizational needs. So it's an abstraction exercise. It's actually quite difficult. Like Geert already said, people are specifically hired to do this type of jobs, let's say functional analysis, etc. So it's not so easy. We try to give some steps in the right direction. And so you don't just write requirements. It's an iterative and balancing effort that works both top down as bottom up. What do I mean with top down and bottom up? Sometimes you have, let's say, a handheld device, so that has, of course, that's a top-down way that you have a dimension constraint. So of course this trickles down to all the way to your PCB sizes, etc. There's also other things. If your sensor is only able to work with this performance, this has of course effects upper on the higher level components as well, and also on your functionality. So both of these things of course balance each other. Why do I say it's iterative? Typically, you don't just write down requirements. It's something that you learn from in earlier exercises. It's something that you specify while learning, and that gets more and more, let's say, specific. In general, what we try to do is, if you have, let's say, these large stakeholder needs that were expressed, then try to allocate these to design categories. These can be very broad at first, let's say application, the product, and maybe service, and then within application you can further make the different subcategories like navigation, system, integration, etc., etc. So first these design categories, that what actually has to be designed, and then further down what we actually try to do is decompose these stakeholder needs into actual requirements. Now, requirements, Geert already mentioned it, these are the rules. They, of course, have to be necessary. They have to be verifiable and unambiguous. There's a whole set of them. So they have to be achievable and complete. And a requirement can only consist of one singular, let's say, performance or feature. So you cannot combine these. And of course, it should be implementation independent, meaning that it should not specify which technology should be used to get to that requirement. I made an example, I already used it. An express need, for example, could be that that device should be handheld. I might have better used the smart coffee machine, but this handheld is a good one because it has a lot of repercussions for a lot of aspects of let's say, that device. And it has physical characteristics going from weight and dimensions. It has a lot of ergonomics and human factors involved. Of course, if it's handheld, it can fall. So that is durability and also reliability, let's say, of your system. Then it probably implies that it is battery operated. So that's of course power supply, battery large, charging ports. It of course has implementation on the way that the device functionality works, etc., etc. So there's a lot of things going on with just one broad expressed need, and that's why I also say this is an iterative process. You don't just come up with that after doing one interview. After that interview, you start making, let's say, mock-ups, and you learn. You learn about form. You learn about weight, dimension. So it's iterative. It's also not that you have to wait until everything is validated to start writing requirements. This is, like I said, it's about maturing the product, where you need to have that life cycle concept finished to finish these system, these stakeholder requirements. But that doesn't mean these don't go together. There's some techniques for stakeholder requirements. I will shortly introduce user story mapping. It might be something you also are aware, are familiar with. So it's typically used in agile development. It employs a concept of user stories, which user stories is sort of an informal description of one feature that is typically used in agile software development. And so we basically describe that the feature of a software system, and it's a very simplified description of a requirement. So this is not the final requirement. Like I said, it has to be unambiguous. It has to be very specific and singular. But this is something you can actually give to a function analysis that then, of course, works further into detail and further in depth. So it's a way to communicate between, let's say, a design or this innovation team that did the lifecycle concept testing to actually going to actually specific requirements. So it works ordering stories along 2 dimensions. I'm just going to show you how that actually works. So you see that high level, there's activities that let's say user has to do, and within these activities there's more specific tasks that have to be performed, and then within each task there's actually a set of user stories. As you can also see, the lower a user story, the less of a priority it is either for the user or for the, let's say, development team or research and development team. I'm not going to say more. There's a last slide and then I'm almost done. The last part is system exploration. Again, you do this also during lifecycle concepts, but in this case, the goal here at the end is to explore, assess, and validate various options that can meet these requirements. For this, it's the last step in our beautiful, not chronologic overview. So basically, what you look at is which enabling systems, so what hard or software is necessary internally in the organization to actually create a product like this, or produce a product. What competences do we lack, do we need? And then, of course, to the product itself, you can explore and assess different technologies and system elements, and you can come up with, let's say, preliminary architectural concepts or system concepts. So that's it. I only have a few slides left, which is that I know I'm jumping from the one to the other, is that we can actually help you implement this let's say knowledge that we've created into COOCK Smart Product. So we have, thanks to industry partnership, a quite good between brackets deal that you can get large part of the cost subsidized. So we have these two types where we can actually help prepare and orient your product ID, or yeah, so what we do, we help you do a sort of a 360 evaluation of that concept, and of course help you either orientate towards what the next steps are, or actually help you define certain validation activities that could help validating your concept. That's it. If you want to contact us, this is mine and Geert's email address and our phone number. So with that, I am ready, and I also thank you for your attention.
And we are still available for questions. If there.
Yeah, maybe just one question if you have like 1 more minute. So clearly there's a very iterative process here. Eh? Well, we showed maybe on a linear timeline, it's not. What kind of guidance would you give in terms of the cycle time between these iterations? I can go very deep into a certain stage before I go on to the next one and iterate back, or I can be very shallow. But it's quite difficult, I think, to get a good feeling on how far should I take that for each of the iterations.
But that's actually the subject of our first webinar in the stage gating, where we where we explain that the stage gating process that is indicated in the Thomas slides on the bottom, that's the part where you already go further in depth and what we call the product research phase. Before that, we start with a problem research phase where it's focused on a low cost pre-study actually, and one thing the way you can approach that is a kind of time box approach where you set a certain budget for a few certain number of people that can with a limited budget work on first exploration of what the problem is to be addressed, and then we make a project plan based on a number of questions that need to be investigated in more depth. And then you really get a kind of stage gated process where we try to, and that's the 5 phases we at the bottom of the slides there, where we will first look at the business requirements, then we go towards the stakeholder needs, etc. But it is kind of, it's not a timeline, it's related to time, but it's maturity
Maturity,
increasing.
yeah.
You increase the maturity, and it's to keep it under control. It's really looking, okay, we define certain questions and we make a plan how much effort that will take. Can we do that? And you control it in that way. This is actually, yeah, it's explained in the first seminar or webinar, and we also have a guideline which is in preparation, which discusses this in more detail. But yeah, it's really a project management challenge to define the right questions and assign proper time and effort, let's say effort budgets to it, and go from step to step. Not what you know, and that is one thing you are referring to in the DipChar case. What they not did right, according to us, is that they, and that is often what happens, go way too far in the product design in the exploration stage. They start really building architectures and board designs for different customized PCBs before you even have established all the stakeholder needs and so on. And in the DipChar case, that went okay. But in other cases, it could well be that you can throw away all this design effort if you stumble on issues. So, and that's what is explained in the guideline in the previous webinar, a proposal how to stage gate this fuzzy front end.
Yeah. Okay.